Okay, so if you're watching this video, then you should have mastered molar mass by now. And so now we're going to work on conversions using molar mass. So we're going back to dimensional analysis. Get it? Dimensional analysis. So remember the steps for dimensional analysis. The first thing you need to make sure is you identify your given. You find out what it is that you have been given, and that's what you write down first as you set up your picket fence. So identify what you have been given, and then you identify the unit you need to be ending with. Like, are you given moles and you need to end with grams, or are you given grams and you need to end with moles? That way you know what you need to cancel out and you're on top of your final fraction in your picket fence. So this is all dimensional analysis, just now using moles and grams. So quick reminder, when you look at the periodic table, remember that 1 mole of like oxygen is equivalent to its mass number. 1 mole of oxygen would be, so in this case, we're going to go through some examples. Our first one, we are given 3 moles of carbon. So we always write down our given first. So 3.0 moles carbon, right? Okay, so far so good. After we write down our given, the picket fence is necessary, and you need to make sure you're writing the units. So set up your picket fence. No, it's not a perfect line, but we'll work with it. So moles of carbon. Now, we want to get to grams, so we need to cancel out moles. So we would put 1 mole down here, right? Because we want to cancel it out. Now, what is equivalent to 1 mole of carbon in grams? We can convert right to grams. This is going to be easy. 1 mole of carbon in grams is equal to its mass number. So if we look at our periodic table, we'll see that carbon's mass number is 12 grams. So what we've done here is we have canceled out moles of carbon. Remember, we're not canceling out the numbers, just the units. And we have arrived at grams. And that's what we wanted to get to, right? Was grams. So we finish our picket fence here, and then we can just do simple multiplication and division. So 3 times 12 is 36. 1 times nothing, 1 times 1, whatever, is 1. So you end up with, as your final answer, 3 moles of carbon is equivalent to 36 grams of carbon. So you see how we did that, how we went through that? Started off with our given, had to cancel that out. Remember, you want to use 1 down here whenever possible. Cancel that out with 1 mole of carbon. And then these two, if they're right on top of each other, have to be equivalent. 1 mole of carbon is the equivalent of 12 grams of carbon. So we end up with 36 grams carbon is equal to 3 moles carbon. So let's go down here, converting the other way. First thing you do is we are given 96 grams of oxygen, 96 grams oxygen. As soon as you finish your given, you set up your picket fence. So we got our picket fence here, right there. Awesome, 96 grams of oxygen. Now, we want to get to moles. This is what we want to end with right here. It's again just going to be a 2-step problem, nothing too difficult. So this is a situation where we can't really use 1 on the bottom, because on top, we're going to have to end up with 1 mole, right? That's what we're going to have to end up with next. So what is the equivalent of 1 mole for oxygen when measuring in grams so that we can cancel it out? Let's look at our periodic table. We'll see that 16 grams of oxygen is the equivalent of 1 mole. What that does for us is we can cross off the grams, finish our picket fence, and we end up with moles. And that's what we wanted to end up with, right? Very straightforward. Grams to moles, moles to grams. That's going to be a constant here. So get used to that. So then we just finish off with our final fraction, and then we can divide. So we have 96 grams, or 96 over 16. And then all you do is plug that directly into your calculator. So I'm looking here, you do 96 divided by 16 equals, and you end up with 6. Sorry, that's all reversed. But you just plug that right into your calculator, and your unit you're using, you got to make sure you continue it, is whatever you had last. So you end up with 6 moles of oxygen as your final answer. If that confuses you, you need to stop and kind of rewatch and redo and practice, because they're going to get more complex from here. Okay, now we are going on to some compounds. So start off with our given. Pause and try to do these on your own if you can do them on your own, and then just look at the solutions. 9.1 moles NaCl. Okay, we take our given. That's always what you do first, and then you set up your picket fence. Picket fence setup. Again, it's going to be a pretty short problem. Now with this, we have moles on top, so we want to put 1 mole down here, 1 mole NaCl. and we want to get to grams. So we've now canceled out moles of NaCl. We have to get to grams. How many grams are in 1 mole of NaCl? Well, that's what we need to figure out. So how you do that, remember molar mass. You calculate the molar mass. If you calculate the molar mass, you'll see that Na, sodium, has a molar mass of 23 grams, and chlorine, Cl, has a molar mass of 35 grams. So you end up with 58 grams NaCl for every 1 mole. So you see why we're putting 58? Because we have 1 mole down here, and these two have to be equivalent. So there's 58 grams for every 1 mole of NaCl. So then we just multiply across 9.1 times 58. And in the end, if we had 9.1 moles of NaCl, we would finish with 527.8 grams NaCl. That would be our final answer. Okay, let's go in reverse. For this one, we would go, start off with our given. We have 114 grams H2O. Set up our picket fence. Right there. Right there. We got to cancel it out, so we got to find out how many grams are in 1 mole of H2O, because we got to end up with 1 mole up here. So how many grams are in 1 mole of H2O? You add up their mass numbers. Oxygen's is 16, hydrogen's is 1, but we have 2 hydrogens, so you end up with 18 grams H2O. Those two will cancel out, and then you just end up with your final fraction being 114 divided by 18, 114 divided by 18, and you end up with 6.33 moles H2O. So if you had 114 grams of H2O, that would be the equivalent of 6.33 moles of H2O. Okay, last two, most complex. And all it is, the only reason it's more complex is because you have to calculate higher molar masses. So again, we start off with our given, 1.9 moles MgOH2. And if you calculate the molar mass, go ahead and calculate the molar mass right now while I set up the picket fence. Calculate the molar mass. Pause if you haven't finished the molar mass. I want you to calculate that yourself. On bottom, we got to cancel it out. We have 1 mole of MgOH2. Always keep your units going. And 1 mole of NgOH2, or magnesium hydroxide, is equivalent to 58 grams MgOH2. And so then all you would do, we have canceled out moles right here, cancel, cancel. And so you just do 1.9 times 58, 1.9 times 58. And your final answer is 110.2 grams MgOH2, or magnesium hydroxide. Always keep your units going. Okay, last example. Start off with our given. I know I'm flying through these. You got to pause and ask questions if you don't know. 89 grams Na3PO4. Calculate the molar mass for that. Pause it and calculate the molar mass. We're going to set up this. We want to end with moles, so we'll put mole right here, 1 mole Na3PO4. Calculate the molar mass of that. You'd have 3 sodiums, 1 phosphorus, and 4 oxygens. So that would give you a total of 164 grams Na3PO4. So those cancel out. Victory is mine. Cancel, cancel. And so then we'd end up 89 times 1 is 89. So your final fraction will be 89 over 164. So you end up with 0.54 moles, 54 moles Na3PO4. So if you were given 89 grams of sodium phosphate, that would only be just over half a mole of sodium phosphate. So hopefully you got that. If you don't, make sure you're asking questions. It's really just 2-step problems, still just dimensional analysis, just converting from moles to grams and grams to moles. But you have to understand molar mass to do this, so hopefully you got that. You'll go on to this paper here. Now that you are finished, moles unit conversions with molar mass is just on the back of the paper you already did. And as you finish that, please have me check over it so you can get it. and molar mass conversions. Have fun. I'm out. Peace.